Okay, let's do a little kinetic energy problem. So the problem that I have for you today is your 70-kilogram friend is going bungee jumping from a height of 10 meters. Question is, what's his gravitational potential energy before he jumps? What's the potential energy at the top of the bridge, assuming he's jumping from a bridge? So again, what you might want to do is just jot down what you're given here. So we're told that your friend has a mass of 70 kilograms and they're jumping from a height of 10 meters. Well, remember from an earlier lesson we said anytime you have anything vertical, a jump, a drop, gravity is an important factor. That's your acceleration. We know that the gravitational potential energy equation is mass times gravity times height. So that is conveniently all the variables that we have here. So we're going to go ahead and plug and chug the information. I've got 70 kilograms for my mass times a gravity of approximately 10. You could use 9.8 if you prefer. And we're jumping from a height of 10 meters. So 70 times 10 times 10 is 7,000. And a kilogram times a meter squared. See, I've got a meter in my 10 for gravity and a meter in my 10 for height. So that squares the meters. Divided by a second squared actually reduces to a joule, which is our unit for energy. So, well, that's nice, but let's take it a step further. Let's see, how fast is your friend going just before the bungee cord pulls him back up? So if we want to know that information, we could apply our law of conservation of energy here. And we could say, well, we want to know how fast he's going when he's moving, and that's kinetic energy. So I'm going to set my kinetic energy equal to the gravitational I just found, which means now I know that EK is 7,000 joules. The mass of my friend doesn't change. That's still 70 kilograms. And I'm looking for speed. How fast is he going? So I'm going to come over here. I'm going to write out my kinetic energy equation equals 1/2 mv squared. And I'm going to go ahead and rearrange this to get velocity by itself. So I'm going to multiply both sides by 2. So I've got 2 times kinetic energy. I'm going to divide both sides by mass. So I'm going to divide by mass, and then I'm going to square root both sides. And now I've got velocity by itself. I hope that was okay to do all that algebra in one step for everybody. Now I can plug in my information. 2 times 7,000 joules divided by 70 kilograms equals velocity. Recall that a joule is a kilogram times a meter squared per second squared, which is like your velocity squared here. So when we square root that, those squareds go away, and then you're left with a meter per second, which is what we want for velocity, so that's good. So 2 times 7,000 is 14,000 divided by 70. The whole thing is square rooted. That's going to reduce to 200. So the square root of 200 is actually 14.14 meters per second. And that is how fast he's traveling. That's pretty fast, right before the bungee jump catches him. Right before the bungee cord catches him.